All right, now we have a very interesting situation. On both sides of the scale, we have our mystery mass, and now I'm calling the mystery mass having a mass of y, just to show you that it doesn't always have to be x. It can be any symbol as long as you can keep track of that symbol. But all of these have the same mass, that's why I wrote y on all of them. And we also have the little 1 kilogram boxes on both sides of this scale. So the first thing I want to do, we're going to go step by step and try to figure out what this mystery mass is. But the first thing I want to do is have you think about whether you can represent this algebraically, whether with a little bit of mathematic symbolry, you can represent what's going on in this scale. Over here I have 3 y's and 3 of these boxes, and their total mass is equal to this 1 y, and I think I have about, let's see, I have 7 boxes right over here. So I'll give you a few seconds to do that. So let's think about the total mass over here. We have 3 boxes of mass y, so they're going to have a mass of 3y. And then you have 3 boxes with a mass of 1 kilogram, so they're going to have a mass of 3 kilograms. Now over here, I have 1 box with a mass of y kilograms, so that's going to be my 1y right over there. I could have written 1y, but I don't need to. A y is the same thing as 1y. So I have the y kilograms right there, and then I have 7 of these, right? 1, 2, 3, 4, 5, 6, 7. Yep, 7 of these. So I have y plus 7 kilograms on the right-hand side. And once again, it's balanced. The scale is balanced. This total mass is equal to this total mass. So we can write an equal sign right over there. So that's a good starting point. We were able to represent this situation, this real life situation, back in the day when people actually had to figure out the mass of things if you were to go to the jewelry store or whatever. They actually did have problems like this, but we were able to represent it mathematically. Now the next thing to do is, what are some reasonable next steps? How can we start to simplify this a little bit? And I'll give you a few seconds to think about that. Well, the neat thing about algebra is there's actually multiple paths that you could go down. You might say, well, why don't we remove 3 of these yellow blocks from both sides? That would be completely legitimate. You might say, well, why don't we remove 1 of these y's from both sides? That also would be legitimate, and we can do it in either order. So let's just pick one of them. Let's say that we first want to remove a y from either side, just so that we feel a little bit more comfortable with all of our y's sitting on only one side. And so the best way, if we want all of our y's to sit on one side, we can remove a y from each side. Remember, if we removed a y from only one side, that would unbalance the scale. The scale was already balanced. Whatever I have to do to one side, I have to do to the other. So I'm going to remove a y. I'm going to remove y mass from both sides. Now, what would that look like algebraically? Well, I removed a y from both sides. So I subtracted y from the left-hand side, and I subtracted y from the right-hand side. That's exactly what I did. It had a mass of y. I don't know what that is, but I did take it away. I lifted that little block. And so on the left-hand side, what am I left with? And you can think of it mathematically, or you could even look up here and see what you're left with. If I have 3 of something, and I take away one of them, I'm left with 2 of that something. So I'm left with 2y right over here. And you see it. I had 3, I got rid of 1, so I'm left with 2. And I still have those 3 yellow blocks. On the right-hand side, I had a y. I took away the y, and so now I have no y's left. And we see it visually right over here, but I still have 7 of the yellow blocks. So I still have 7 of the yellow blocks, and since I took away the exact same mass from both sides of the scale is still going to be balanced. It was balanced before. I took away the same thing from both sides, and so the scale is still balanced. So this is going to be equal to that. Now this is starting to look a little bit similar to what we saw in the last video, but I will ask you, what can we do from this point? What can we do from this point to simplify it further? Or so even better, think of it so we can isolate these y's on the left-hand side. And I'll give you a few seconds to think about that. Well, if we want to isolate these y's on the left-hand side, these 2 y's, the best way is to get rid of this 3, to get rid of these 3 blocks. So why don't we do that? Let's take 3 blocks from this side, but we can't just take it from that side if we want to keep it balanced. We have to do it to this side too. We got to take away 3 blocks. So we're subtracting 3 from that side and subtracting 3 from the right side. So on the left-hand side, we're going to be left with just these 2 blocks of mass y. So our total mass is now going to be 2y. These 3 minus 3 is 0. And you see that here. We're just left with 2y's right over here. And on the right-hand side, we got rid of 3 of the blocks, so we only have 4 of them left. So you have 4 of them left. So you have 2 of these y masses is equal to 4 kilograms. Because we did the same thing to both sides, the scale is still balanced. And now, well, how do we solve this? And you might be able to solve this in your head. I have 2 times something is equal to 4. You could kind of think about what that is. But if we want to stay true to what we've been doing before, let's think about it. I have 2 of something is equal to something else. What if I multiplied both sides by 2? Or sorry, what if I multiplied both sides by 1/2? Or in other ways, dividing both sides by 2. If I multiplied this side by 1/2, if I essentially take away half of the mass, or I only leave half of the mass, then I'm only going to have 1 block here. And if I take away half of the mass over here, I'm going to have to take away 2 of these blocks right over there. And what I just did, you could say I multiplied both sides by 1/2, or just for the sake of little change, you could say I divided both sides by 2. And on the left-hand side, I'm left with a mass of y. And on the right-hand side, I'm left with a mass of 4 divided by 2 is 2. And once again, I can still write this equal sign because the scale is balanced. I did the exact same thing to both sides. I left half of what was on the left-hand side and half of what was on the right-hand side. It was balanced before, half of each side, so it's going to be balanced again. But there we've done it. We've solved something that's actually not so easy to solve, or might not look so easy at first. We figured out that our mystery mass, y, is 2 kilograms. And you can verify this. This is the really fun thing about algebra, is that once you get to this point, you can go back and think about whether the original problem we saw made sense. Let's do that. Let's think about whether the original problem made sense. And to do that, I want you to calculate, now that we know what the mass y is, it's 2 kilograms, what was the total mass on each side? Well, let's calculate it. You have 2, I'll write it right over here. This is 2 kilograms. I'll do it in purple color. So this is a 2, this is a 2, this is a 2. So we had 6 kilograms plus these 3. You had 9 kilograms on the left-hand side. And on the right-hand side, I had these 7 plus 2 here. 7 plus 2 is 9 kilograms. That's why it was balanced. Our mystery mass, we had 9 kilograms total on both sides.